Okay, now we're going to continue with our next talk. I'll let Jimmy explain everything about his lightweight embedded hypervisor.
Hi, thank you for being here. It's nice to see so many people. And I will talk about FOSDEM. You can see this on the planning since I didn't know I couldn't put such a long title. But the topic will be hypervisors. So this one will be FOSDEM. So let's begin. Sorry for the format. Okay, so just the context, okay? The projects. I'm Jimmy Durand-Wazalowski, long name also. I'm working at OpenWide, a French company that is doing open source software, servers, and engineering. So you will have all the details at the end of the slides. You will have the slides in the end, and everything. Yeah, you see more about. I will not show this, but you can take a look. And I'm working in the Technological Research Institute of System X in Saclay, France. Okay, the context, the hypervisor is in the car. It's a solution we will use, but it's just the context. The topic is FOSDEM. Okay, just to be sure, quick definitions. I think you all know that, but just to be sure. A virtual machine is an efficient, isolated duplicate of a real machine, just to be sure. Okay, I think everybody knows this, but okay, let's give a quick definition. An hypervisor is a software or firmware, depending on the classification. We'll talk about this later. That creates and runs virtual machines. We will call them guests. And the hypervisor is the host. We invite guests on the board. This relies on virtualization support on the host CPU. You use the CPU to execute instructions. The guest's instruction, to be more precise. This is different with an emulator. An emulator is a fully duplicated real machine. You also see a full real, from a guest point of view, a full real machine, but the CPU is emulated. You translate the code. So for a quick classification, there are two types of hypervisor. Which is called bare metal, the type 1, and the one on an OS. Okay, just to know, for example, okay, we will explain the classification. The bare metal has a better isolation and an improved reliability. And of course, it can be smaller since it can be, it doesn't have to be full OS. But for the type 2, you have lower costs. That may be interesting. No additional drivers, so less development, but it's a full OS. For example, you have for type 2, VMware Workstation, VirtualBox. You know VirtualBox or VMware, I think. KVM and Beehive. Okay. For the type 1, you have VMware ASX, SXI, Xen, FOSDEM, or hypervisor, the one we are working on, KVM and Beehive. Okay, nothing curious. It's just, okay, KVM and Beehive are more qualified as type 2, but as it is running directly on the hardware, there may be a confusion, but it's more likely to be a type 2. Just a precision. Okay, let's talk about FOSDEM. Few words. It's a great project, very well designed by Anup Patel, who launched the project in 2010. His first version was released in October 2011. 010, okay. Now we are 250. 13 contributors. It's growing very fast. So it's interesting to go in the project now, since there are few contributors. You can submit ideas, you can do whatever you want with it, and if you think you have a good idea, please tell Anup, tell us what you think. Many commits, it's already, you can already play with it. There is a demo I will show. It has a high performance and low memory profile, low memory footprint, a large support with many ARM platform, and x86-74. It's working on our QEMU for tests. It can be really, really useful, and you can give a try. You can test. You can now, with your laptop, clone the last repository and give a try. There are already a support for many platforms. Everybody know the Raspberry Pi. There is the VExpress A9 that you can use also on QEMU. And our board, the Satellite Nitrogen C6, is supported. The QB board too, also. So it may be interesting. And the configuration is really simple. So it can be very, very easy to go in testing and then contributing if you want. It supports different type of emulation. I'll talk about this later. And it is fast. Can be interesting. Anup Patel wrote a research paper, very interesting. I hope this will be released soon. Some tests have been done at that time. It's faster than KVM and Xen, and it has better read, modify, write operations, so better throughput. There are many features like a Linux. The framework is really like Linux. I will share this. There is already networking, telnet daemon, loadable modules, and very, very nice features for emulation. For example, if you want to support your board, you have Linux drivers for your board, you only have to introduce the API, okay, globally. A simple vision. For example, completion, easy. Radix tree, okay, nothing to do, perfect. But of course, some layers are not implemented yet. Of course, it's still a small project. And some mechanisms are simplified. And of course, because it won't be very fun if it was working already, you know that manufacturers and developers have to do sometimes some workarounds in drivers for Linux. You have layers, and you have to deal with them, and the hardware is not perfectly adapted. So that leads to bugs. And for example, if you watch the MMC SD management in Linux, you have 3 layers: the MMC layer, the SDHCI layer, and the driver, finally, to support the hardware. Sometimes the MMC layer is doing something in Linux, which is not completely, the behavior can be a bit different since it's simplified in FOSDEM. And we had many problems with this. You can port a driver in, I will say 1 week, but sometimes it can be one or more months. So it's easy, sometimes painful, but not every time. Just to show you the configuration. It's not working. Okay. Perfect. Okay. This is an example of configuration. If you know device tree, you already know this. It's quite the same, not completely the same syntax, but it's very close. For example, what we have here is the configuration of the host, the upper layer. It has been split in multiple files to be more readable. If you look in Subolite board configuration file, you see something. It's for this platform. We tell exactly what we have in our board, exactly like in Linux. And this is the board, very, very, very similar to what we have in Linux. So porting is easy. And finally, the host, the hypervisor is very, you can have a very easy configuration, but also the guest can be really simple, as it is the same thing. You have a device tree, you put exactly what you want where you want. For example, we would like the board to know that there is PCI, but we will not, for I2C, but we will not use it, so it's virtual. And we define a memory area. Okay, just to show you a bit. Let's continue. I told that there is multiple way of emulating. For example, you have, let's say you have a FreeNV OS, a Linux. You don't want to modify the drivers. You can emulate, completely emulate the device, okay? Of course, that is useful, but you may want to have a quick memory interface. You may want to have direct memory management, direct memory access, so you can configure through the emulator a pass-through here to have a faster access to hardware. You can do power virtualization with or without VirtIO, virtual input output, to communicate with drivers and finally with hardware. And we see there the configuration files. I specified this one also. If you have Linux, there is also a device tree, 3 device tree that are used and quite similar. Okay, now this is just to show you how the memory protection is implemented. The FOSDEM support ARM32 without virtualization extension, which is really, really cool. Of course, it relies on software, but you can use them So if you have a simple board, you can use FOSDEM and have a fully useful hypervisor. You can, of course, use it with virtualization extension and hardware-assisted material. Just a point here. There may be something strange. They are both in user mode. But it is protected with domains. So the user space, the kernel is protected from the user space, thanks to memory domains. I don't talk about x86, I don't know. You can ask Anup if you have a project on x86. Okay, how do we do this? There is a translation. We have a guest virtual address, which is translated into, which is called an intermediate physical address. Like it's the virtual address of the hypervisor, FOSDEM, and finally translated with the host MMU into a physical address. So here it can be hardware if you have virtualization extension, or it can be software if you don't. Okay, in order to do this, for example, emulators at execution time check what is done in the code. We do not want this. It's too slow. We are embedded. We want speed. We want to be closer as possible to the hardware. We want the same behavior. So this is done offline. You have your binary. You have to know where your code is, which is why we use, for now, we use the ELF format. We know where code is, where data is, so it's easy to know where are the privileged instruction, and we translate it into hypercalls. I don't have time to explain all this. It's very interesting, but it's a bit long. There are slides from Jim Hong that you can find on the internet, which explain this very, very well. Okay, just some links to know a bit more. There are many things, many cool things to do. So if you want to contribute, please do. It's really interesting. It's fun. It's a really nice project. It's very, the community is growing every day. There are many, many commits per day. So if you want to give it a try, please do. Use it or contribute as you wish. A few links also with Jim Hong slides. And I will try to show you a quick demo. Okay, I'm sorry, since I use a feature which is not really well implemented. I plugged the USB while my computer was sleeping, so I have to reboot just to be sure. Okay, KExec, thank you. If you have questions, we can talk about what you want just after, since I don't want to take too much time. Okay. Okay, perfect. fine. Okay. It's okay. Full time, yeah. So I'm running scripts on my GTAG probe. Okay. What we see here is not very useful. Okay. This is more useful. You see FOSDEM running. Okay, the errors are because of my SD card, which is not ready. You have a good monitoring of what are the drivers running, what are the guests running. Well, everything we want to know about the status. And as you can see, there is already support for a screen. If your screen is not, you just have to change the device tree configuration, and if everything goes well, your screen will be supported. So, okay. For example, we can change the backlight. It's not very fun, but you can see something. The problematic of embedded devices. Okay. Okay, off, full powered, half powered, etc. You can add your commands. This command didn't exist at the beginning. You can add very, very easily commands and debug everything you want. And if you have a GTAG probe, you can do whatever you want with FOSDEM. It's quite simple. So here it is, FOSDEM. If you are interested, please, we can talk later if you want. Thank you for being here. Thank you for your attention, and enjoy FOSDEM. Thank you.